Hey people, we've got a heavy one here today, and I don't mean heavy as in the emotional sense. I mean heavy as in this thing is an absolute unit. And if you're at all familiar with these things and how much they weigh, you may have noticed that I didn't struggle too much to put it up on here on the bench. And that's not because I'm like super strong or anything. I mean, I'm not a total weakling either, but that's only because I have actually already removed the batteries that go inside of this thing. And this thing alone weighs about 54.5 pounds or 24.7 kilograms if you're into the other flavor of measurements. Each of these batteries weighs about 26.5 pounds or 12 kilograms, which means that in total, this thing would weigh about just over 100 pounds or about like 50 kilograms. But why am I telling you all those measurements? Are they really important? No, that's just mostly to help you understand how frustrated I am with the fact that this thing has failed. See, I actually built a shelf here underneath my workbench, and that's where the PC that I use here for all my captures and all my work and stuff, and this UPS would reside. And it's kind of like down there, and it's blocked in the front by another table that I have here to my right. So everything goes there, everything connects down there, and so trying to get access to this UPS is a real pain in the butt. And unfortunately, it seems to have failed after a power outage that we had one night. It was all working fine for about 2 months, and then just out of nowhere, it seems to have crapped out. Now, I know you might be thinking like, well, maybe the batteries are just dead. And I would be inclined to think that as well, except for the fact that these batteries are just over 3 months old at this point. Like I had just recently bought them. And if we check the voltage on them, we can see that these are 24-volt battery packs. They have two 12-volt batteries in each pack here. So this top one here, 25.678 volts, and the bottom one, 25.667 volts. So it appears that this unit did charge them after the power outage, but for some reason I cannot get it to turn back on again. And normally, if the power would go out and the batteries died, as soon as the power came back, the unit would just turn itself back on. And I've tried resetting this thing. I don't believe that it's a like an issue that's been caused by, you know, like the firmware or something, like just kind of crapping out. It does have a serial port in the back, and I tried connecting to that to a computer to see if maybe like, you know, it spat some data out or something, but I had no luck with that either. So I'm starting to believe that the issue might be electronic inside of here. So let's open it up and see what we can figure out, if I can get this thing working again, because it really is kind of handy to have. Now, I think that the top portion here can all come apart without having to take off anything from the bottom, except for this battery cover. But there's two screws, I believe, down here. So, oh no, there's one screw right here in the middle. That just holds this front panel here in place. And I know I took this off once. Oh, there it goes. Okay, there are no other screws here. I'll flip it over here in a bit so we can get a better view. But I'm just going to put that back on for now. There are these screws in the back that I'm sure need to come off so that the top cover can come off. All right, so that's all that. I think this just kind of comes off like a PC case cover. Yep, sure enough. Yeah, there it goes. All right, let's flip this over to the side. And here we go. This is the reason why this thing's so heavy. You got these two like heavy iron core transformers, and then I mean the inverter board it's kind of dense, but it's not like crazy. The bulk of the weight comes from those transformers and the fact that this chassis is all like steel. And you can see how they've installed this strap here to just kind of provide some rigidity there to the frame. There are some connectors right here that house a fuse. We can check those and see what's up with those. But like I said, I don't believe that these are going to be an issue because the batteries do charge. At least I'm pretty sure that they did charge. Unless this thing failed before the batteries had a chance to like completely die out. Okay, so let's see. Here's one of the fuses, and this is a 250 volt, a 15 amp fuse. So let's see. Yep, nope, that fuse is fine. And this other fuse is another 250 volt fuse. This one is also 15 amp. That's fine. I'm trying to freehand this a bit here so we can take a look at the board, but first glance that I kind of took a look around, I don't see anything that looks burnt or anything. There's a 230 amp fuses down there. I think we can check those too, but I'll do that from the other side of the board. We see we've got some relays, capacitors. We've got two of these like pretty tall, huge caps. Look how long those things are. Looks like they're about like 4 inches long. There's where one of the big battery terminals goes. The other one goes directly to this heatsink right there. This right here is where one of the transformers hooks up to. The other one, it's connected in series with the other transformers, so very high current transformers. And that's where the other terminal of the other transformer goes. So I believe that the MOSFETs that are mounted on here on these heat sinks are not just used for like switching the transformers to produce an output voltage, but they're also used as the rectifiers for charging. So one of the things I might want to check here is see if like any of the MOSFETs that are mounted to these heat sinks are shorted. And if we take a look here, we can see that we've got 1, 2, 3, 4, 5 MOSFETs. It has room for 8, but it's only got 5 per heatsink. Well, let's go ahead and take a look at those fuses then and see if those are blown or not. Without removing the entire board, the only access I have to those is like right here on the side. And it doesn't look like they are both connected in parallel. Looks like one goes off this way. The other one goes off to another set of vias right there. And it looks like the other side is connected. Both of them are connected together. So we can check one at a time by, let's see, doing this. Actually, I think what I'll do is I'll bring the multimeter up here on the top right. All right, there we go. Now we can have a visual there without having to keep the multimeter in the shot. So let's see what these fuses measure here. I got that's totally fine. Check the other one, and that's totally fine. So doesn't appear to be fuse related. Let's check the MOSFETs and see if any of them are shorted. Now, with the exception of the base of each of these MOSFETs, the drain and the source are all connected in parallel. So we can actually, if we check one, we'll know if there's a short like in the entire section there. So if we check this bottom one, this here would be the source, this here would be the drain, and it's not shorted. The next row, that's not shorted. And I could probably make it easier on myself if I just check it from over here from where these unused pads are. That way I can just tap it like that. That's not shorted. And the top row, that is not shorted. Guess we could also check the base. We can check from the source to the base. And let's see. Nope, nothing there. Well, I guess we could check them all, huh? So there, nothing there. Ooh. That's no bueno. Uh-oh. That one seems to be shorted. That is not shorted. That is not shorted. Huh. Okay, let's check the next row. No short. No short. No short. No short. No short. And these are all mounted in the same orientation, so that's why I'm just kind of like going straight across like that. So third row, no short. No short. No short. No short. No short. Fourth row, and that one's going to be a little difficult to get to. I'm probably just going to have to do it from the top of the case up here because I can't really access this first one. And I'm touching the heatsink, so that's why I keep getting a short there. But all right, there we go. So no short there. Can I get the next one from here? Yes, I can get the next one from down here. No short there. No short there. Nothing there. Nothing there. So yeah, it looks like this one right here. Which one was it? That one. Oh, I see what happened. I was accidentally touching both the resistor here, like where it comes from, like the driver for the entire bank of MOSFETs. And so for some reason, yeah, like when I touched wait a second, no, that doesn't make sense. Because even if I would have been touching this and here, that doesn't do anything. That doesn't do anything. This is the only one that reads 20 ohms. Let's see what these resistors are supposed to measure. So that's 1.25. Okay, it's rising. Uh-oh, it seems I spoke a little too soon about nothing being fried. So I should have checked the value of those resistors before I started testing them. But because I was getting such funky readings there, I decided to shine the light in here and see what the resistors were supposed to be. And check this out. Yep, there it is. Blown MOSFETs. So looks like this bank of MOSFETs here, fried. Oh yeah, looks like yep, some of those right there went a little explodey as well. None of the ones up here look like they're damaged at all. All of that's good. So it's these two right here where the positive of the battery and one of the transformers connects to just completely got blown out. So those resistors are supposed to be 20 ohms. So it appears that maybe that one that measured 20 ohms was the only one that's good. Some of the other ones got burnt up. So I think, well, I mean, I'm going to have to remove these plates and to get to those MOSFETs because, yeah, there's no other way to get to them. And I think I should be able to remove those two plates without removing the entire board. Start off by taking off this sort of a air guide here for the fan, because the fan is mounted back here, so this kind of helps direct some air like kind of across. I'm wondering if this thing overheated from being down there. Maybe it just wasn't getting enough airflow. You wouldn't expect something like that to happen, really. It's not like crazy hot in here or anything like that. Now this brace here just kind of helps the plates stay kind of separate and not be able to like move close to each other or anything like that. This plastic piece right here just has it's used to secure those two big capacitors. That it's like some sort of a knuckle thing. Set those aside. All right. Got to take off those two screws. And that's going to be 10 MOSFETs that I probably don't have on hand. So I'll have to remove the solder from all of these. And then these mounting pins right here on the ends. This one right here is going to be a little difficult to get to. Actually, not really, because it's a little hard to see right here, but it's like right in line with the edge of this plate right here. So yeah, looks like it should be doable. Actually, I'm starting to think that I might be better off removing the entire board. I just realized that there's a couple of kind of dark looking spots right here, as you can see behind the board. I noticed those. When I looked at the other side, those resistors look a little crispy, so I think I'm going to have to remove those as well. And I bet you that those are probably drivers for these MOSFETs. Okay, so I took a few pictures just to make sure I had a good idea of like where everything hooked up on the board. So I don't have a hard time remembering, just in case something seems a little too ambiguous. So I'm going to disconnect everything now. And there is one screw over on this side that appears to hold the board in place. And then it looks like the board will just kind of like slide forward and it should come off. There are some connectors down there that are going to be a little more of a pain to get into. Looks like I might have to remove this box right here. This box is for like an add-in board that you can, there's I guess various different boards that could have been installed in that spot, but there is nothing on this one here. It's just an empty box, but I am going to remove it just so I have an easier time accessing that connector down there. Just like that. And then there's a connector in the front. There we go. That is out. Yeah, so there's a connector down here, needs to come off. There's another connector towards the back. Actually, I might have an easier time accessing that once the board slides up. So there is another screw back here that is screwed into a ground strap that's soldered directly onto the board. So that needs to come out. And it's got a pretty long screw. I wonder why they made it so long. Maybe in case it was a little difficult to reach from the outside of the board there. Look at that. But that strap is like touching directly onto the back plate right here. So yeah, they just made that one kind of long. Okay, looks like that's it for that. Need to pull this negative, terminal here off. And what I should do, so I don't misplace any of these, is put them back where I took them from. Okay, and I'm going to do the same with the screws for the transformer terminals and the positive of the battery. And unfortunately, the ribbon that goes to the front panel is soldered directly onto the board there, and there's no way to remove it from the little control panel. But the control panel will come off with just these two tabs right there. Looks like I just pull those up, and there we go. So just lay that there so I don't accidentally tear it off. Looks like that should be about it for removing this board. So there's a screw right here that I said. Looks like that might release the board and allow it to slide forward because it's mounted on these little tabs right here that fit into these grooves. So let's see if that does it, because I can't see any other screws from where I'm sitting. So, no, there it goes. Look, it's loose. Cool. So that just lifts up like that. Looks like I can just bring it forward. And I have one more connector to undo back here. There we go. So here's the rest of the enclosure with just those two heavy transformers. This thing is still heavy, but at least now I can set this down and just work on the board itself, because maneuvering this thing up here is, yeah, it's been quite a pain. Now this UPS is actually one that I've had sitting underneath my bench here for like the longest time. And I never used it and didn't have any batteries. I was given this like, I don't even know how long ago. It's been way more than 10 years. But I decided to start using it because lately it seems we've been getting a lot more like brownouts and power outages. And I don't know if it's due to the fact that there's been some construction going on here like nearby within the last few years. I don't know if it's related at all, but if I can get this working again, it'd be nice to have. I'd rather not have to pony up the money for a new one. And like I said, I've just bought the batteries not even that long ago, and they weren't exactly cheap. I paid like almost $230 for the set. But yeah, look at that. There we go. These are IRF 3710 MOSFETs, and I believe that they're all going to be N-channel MOSFETs. I don't think that I've taken a few of these UPSs apart before, not this exact model, but similar ones, and they all use the same type of MOSFETs for both the positive and the negative rails. But since this is accessible here and those are all burnt up, I think it's going to be easier if I just clip all the leads, and then that way all I have to do is focus on unsoldering the tabs so I can remove these plates. These rivet looking things right here that are holding on the MOSFETs to the plate are not actually rivets. They're screws. They just a little weird looking and they're hollow. But I'll show you how those can come off here in a second. So let's start by cutting off all these leads here. Whoa, that one there is just completely in pieces already. I don't think it's even going to need me to cut all these clips off. Nope, see? This one here appears to be the same. Just need to cut the drain lead right there. This one here looks like it's just going to pop off as well, or maybe not. All right, let's just cut it. Okay, so now this is a bit looser. And now I can basically just get my soldering iron on here and maybe just add some solder there and just melt those off while I pull up on the other side. And this is kind of a heavy board, so it's going to take quite a bit of heat here to get that to melt. Okay, there it's gone and melted there, and now let's add some more to here. Okay, now I'm on the other side, and I'm just going to kind of rock it. You can see it there that it's kind of moving a bit. So hopefully while it's molten, it will pop out. Let's heat up the other side a bit. There we go, that side is out. Now I just got to get this side out. And after it's out, I should be able to clean up the holes. There we go. So there's the first one. Nice and crispy MOSFETs. Oh man, that's going to be a little more difficult. I can't just reach in there and cut off the pins because these capacitors are in the way. Got a little remnant right here. That out. All right, so I guess my next strategy then for this is going to be to remove these screws that I'm talking about here, and then that way I can pull all these MOSFETs off the plate, and that's just going to leave me with the plate to desolder, and that way I don't disturb any of these capacitors. So let me find a Torx bit that will fit these. All right, so I've got a T8 here. That's a Torx 8. That seems to fit fairly well there. And I just have to like push it in there. And that should help. So I'm going to get an extension because trying to get a screwdriver right here is going to be kind of difficult with all these relays. But if I have a long enough extension, then I can put the bit on the end there and then just have the screwdriver like way out here. And I should be able to remove all of those. Okay, so I thought to myself, we've got one extension, yes. But why don't we use two? So I'm going to put this here on the end. Put the bit there. Attach this to a screwdriver. And we can go and remove these screws. Here, I'm going to do it like this so that you can get a good view of it. And there they go. So I'll show you what these screws look like a little better here in a bit. But yeah, they're basically completely hollow in the middle. Let's just go ahead and remove them all. And so not only are these all going to have to get repaired or replaced, but I'm also going to have to check some of this drive circuitry over here. And I might even replace these screws while I'm at it because I don't really like these. Like they're kind of like I said, a Torx, but because they're hollow, they're kind of weak. And so they tend to strip a bit. Like I can already feel these sort of like stripping a little bit as I'm unscrewing them. Yeah, right there. See, that one's like slipping. So I have to put like a lot of pressure on it to be able to keep like a consistent motion on it there. And then got to pry them off of the bit. So now these will not hinder me anymore. Just kind of move those off to the front. Here's a much closer view at one of these screws. And I guess I was wrong about them being like a Torx. They're actually more of like hexagonal shape in the middle. It just kind of looks like it's got these sort of like little dimples that kind of come out of each one of the corners there. So that actually kind of helps the Torx bit kind of set in there and bite in there a little bit. So that's always how I remove these. And it always seems to work okay. And now I can remove that second plate. And if we take a look at that other section of the board, you can see those other resistors that got burnt up right there. That one there looks no bueno. This transistor right here looks like it got a little hotter than it should have. Yeah, that's crispy. Move a little bit further down. We can see the other resistor right there. Another transistor right there that looks like it, yeah, the front of it blew off partially. Now, unfortunately, all the color's burnt off of those resistors. Hey, there's a little fuse down here. I wonder if that's any good. And I just realized this entire time the multimeter reading or readout has been up there on the top of the screen the entire time. So while we're here, let's check this fuse. And nope, it's good. Kind of doubt this resistor here has anything left, but let's check it. Let's change the range here because I only have it on 3K. Let's just set it to auto. See what it says. Oh wow, 4.7. So that might be the same as like this one here then. Because I do notice that they're using like doubles in some of these sections. Like for example, up here where the other resistor burnt right there. Look, they got a 4.7K resistor right here. Yeah, right there. And then they also have one right here. And then this right here looks like a, what's that, 3.3K? Yeah. So I'm wondering if that one was supposed to be a 3.3K as well. As you can see, it's reading 3.7 megohm right there. But yeah, that's not going to be right for this. So I guess I would have to see how exactly these are wired on the board here to determine whether or not this is that's going to be the correct value. Oh no, people, it keeps getting worse. So I saw this transistor right here that looks like the side of it like blew chunks out. And then I noticed that there's a trace going from that pin snaking around over this way underneath this IC. And then I saw that right there. This chip also burnt up. And you can see that looks like there might be a tiny little hole right there somewhere, unless it just sort of like spattered. So this chip here fried as well. And the number on that says APC 2010. So that appears to be a, I don't know, it says on semiconductor here, but I don't know if maybe this is like a standard chip that's been renumbered into APC 2010 or what. And unfortunately, I don't know that this is going to be something I'd be able to replace. And it just seems like it's getting worse and worse. So who knows if this chip here could have damaged something else. Looks like some of the pins from here go underneath this IC, but I don't know if any actually make contact with it. That's a CD40-106. So this here, we'd be able to like find a replacement for most likely. But then here's another chip that's also APC numbered, 2208 looks like maybe. So now I don't know if this one is damaged as well. Woohoo! There's an earthquake right now. Yep, things are shaking. That's not me shaking the bench. Okay, people. Well, as much as it pains me to do this and let everybody down, I think I'm going to have to call it quits on this one. The fact that these two APC numbered chips here, I cannot find like a data sheet for or anything. And you do find some links online that says like, you know, where you can buy them, but it seems to be sites like AliExpress and then some other kind of dodgy looking sites. I don't want to risk trying to buy these ICs with the hope that this thing is going to work, and then I just end up blowing a bunch of MOSFETs again. But it's way too much of a gamble, in my opinion, to try to get some potentially dodgy components. The other thing that kind of sucks as well is that, I mean, there's no schematic that I'm going to be able to find for this thing. If I was able to find a schematic for it, maybe, you know, we'd have a chance. I think I'll just take the money that I would have spent on this one and invest in something else. But at least I got two nice, huge transformers out of it, I guess. And I still do have those batteries, but I don't really have anything I can just stick them in at the moment, but I can use them for something else, so that's not a total loss or anything like that. It just sucks that I was only able to have this thing working for 2 months before it crapped out. So, yeah, I think that's gonna do it for this one here, but, I mean, at least we recorded a little bit of an earthquake while we were at it. Alright, so, sorry for the disappointment, but thank you guys for watching, and I will see you guys around the bench.